Hello and welcome to this video, the final one on oligopolies and pricing strategies that oligopolists adopt. We're going to focus on the Nash equilibrium in this recording, as well as the idea of collusion, and also another topic which didn't make it into this this heading. I'm going to talk about the price and output decisions as made by those who compete in oligopoly markets. Okay, let's start with the Nash equilibrium. It's a really important concept, and it derives from a branch of economics or even mathematics called game theory. Game theory is the set of tools used by those who compete in what can be described as games. I mean, in this case, it's competition in an industry. It's the tools used by competitors to decide their optimal strategy, taking into account the anticipated actions of rivals. So we're going to rely very basically on the tools of game theory. And let me just state that this idea of the Nash equilibrium, it's a condition which is present if, right, the participants in a non-cooperative game, so basically a competition where they do not cooperate. Obviously, we're using the term game to describe the rivalry between companies, firms in a given industry operating under conditions of an oligopoly market. So present if participants in a non-cooperative game have absolutely no incentive to deviate, to change from their adopted strategies, chosen strategies. Obviously, strategies concerning, for example, the level of the price and the level of output, but most importantly, price after they have considered, after considering and also anticipating, this is very important, anticipating the rational choices or strategies of their rivals. Now, this is, this is a very long definition, and in a moment, in a question, you'll see how we can turn that into a testable example. So the idea is, in an oligopoly, you cannot just make decisions independently. You have to anticipate how your rivals are going to react to your decisions. Nothing can be done unilaterally. That's, I guess, the concept. And every company will do what is best for it, but given the anticipated reactions of rivals. I think that's all we need to start the question. So let me show you the question that I've created. It kind of mimics what you can find in your curriculum as well. Two firms, A and B, control the market for a product. Each can charge a high or low price with the following economic profit outcomes. And on the left-hand side, you see the choices that can be made by A with regard to the price it charges, low price or high price, and the same is mirrored over there in the columns for B, low price and high price. And obviously, at the intersection of all those choices, we've got four possible outcomes of A's profit and B's profit. And we're asked to locate or find the Nash equilibrium. Which kind of quadrant, which cell is it likely to be? So we're going to have to find the combination of A's and B's choices with regard to price, where neither A or B have an incentive to change anything, to deviate from their chosen strategies, given the anticipated reaction of their rival. Okay, so how do we go about this? Well, first of all, let me just say that this requires a little bit of luck to start with, because what you'll have to do is you'll have to find a point where one of the competitors has a clear advantage to choosing one of the options. So if I started with A, which is not the sort of the ultimately what we're going to end up with, but if I started with A and said, okay, what if A chooses a high price? What would B do? Well, B would go for a low price over here because that maximizes their profit at 110. What about if A charged a low price? Well, then B's response would be to choose a high price because that maximizes its profit. Well, I'm not going to go anywhere. I'm not going to get anywhere with this because I cannot find a sort of a single response by B to A's actions. So let me try the other way around, and I can assure you that this will work. You'll see what I mean in just a moment. So starting with B's choices now. If B were to go low price that is, what would A's rational decision be? Well, if B chose low, A should go for a high price over here, getting a profit of 80. So A should choose high. That's the idea of anticipating your rival's choices, right? What if B were to choose a high price? Well, let's see. If B were to choose a high price, A would maximize its profits. Once again, by choosing a high price, 130 is definitely better than 60. So A should choose high. So we found a very clear favorite for A to choose, irrespective of what B does. Now, if I started the other way around and I was thinking in terms of if A chooses low or if A chooses high, we didn't have a clear favorite, a clear outcome for B. It was either one or the other, but not the same choice in both instances. But this is really helpful. Given this, right, I can say that whatever happens, A will choose the high price alternative. They'll go for the high price. And now, given the above, so given that A will choose the high price, what should B go for? B should choose, well, what's best for B? If A chooses high, B should choose low. That gives them 110 of profit, which is better than 90. So this quadrant over here, where A goes high and B goes low, basically what's written over here in answer B, that's going to provide your Nash equilibrium. That combination of choices, A going high, B going low. And once they are in there, they will not move from this because they know the likely response of their rivals. Okay. B doesn't have an incentive to go and charge a high price because that would make their profit lower. At the same time, A doesn't have an incentive to go for a low price because that would make their profit low. I mean, this is the natural equilibrium point. However, the idea is, and this is important, you may be tested on this, right? So this is going beyond the question now. If you sum up the profits over here for this Nash equilibrium quadrant, 80 for A and 110 for B, you get a total profit, don't you, of 190. So total profit over here is 190 coming from A and B. This is a point where A is generating 80 of profit and B is generating 110, which sum up to 190, of course. However, please note that if there was some way of moving the companies to this quadrant over here in the bottom right-hand corner, that would make the overall profit here higher. 130 plus 90 gives a total of 120. So potentially there is this to go for, 220. I may have mistakenly said 120. 130 plus 90 is 220. So this is possible to achieve if both companies choose a high price. However, this comes from the fact that A's profit would now increase to 130, which is an improvement, a gain of 50, but B's profits would drop to 90, which is a loss of 20. Obviously, this is 30 up from in terms of the total, but it comes at the expense of B losing 20 and obviously A gaining 50. This is a higher profit for the industry as a whole, or for these two competitors as a whole. And A may try to convince B to collude, basically to get together and create some kind of agreement, which if it was formal and openly known, public, we would call it cartel. And they would decide, okay, let's both charge a high price. But because this is only beneficial for A would have to pay B something to adopt this high price strategy, because obviously B is losing over here. And A would have to pay at least 21, well, something more than 20 to B to compensate for the losses that it suffers over here. But obviously the gains that A makes over here make up, or very much cover what they would have to pay B to move out of this corner, which is the Nash equilibrium. Time to move on to the second topic of this video, that's collusion. Collusion is obviously companies cooperating in an oligopoly market. Let me just state, however, your book does make this point, that if collusion takes on an open format, that is, it's publicly known information, it's formalized, open and formal, we call such an agreement a cartel. So the companies belong to a cartel. And I guess the most famous one, the most famous cartel, which your book actually talks about, is OPEC, the Organization of Petroleum Exporting Countries, that sets prices in the crude oil market in the interest of its members. Okay, now we're going to discuss when collusion is more likely to happen or less likely to happen. So what factors actually influence the success of collusion, irrespective of whether such agreements are legal or not. That's kind of besides the point. So let me write factors affecting the success of collusion, which will both include factors that make collusion more likely than not. i.e. that an agreement of such an agreement is struck in the first place, and then once it's in place, will it actually hold? Will nobody break out of such an agreement and break away and do something independently? Because at the end of the day, typically it's all about keeping prices high, even if maybe one of the competitors may want to do something independent and undercut their competitors by making their prices lower, which typically triggers a price war that is going to be detrimental generally to the industry, not to the consumers, but not to the buyers, but the producers. So in order to avoid a price war, they often have a more or less formal agreement in place. Okay, let's start with the first factor. That's the number of firms in the industry and their size. Let me perhaps write over here the heading collusion is going to be successful if, so the condition that makes collusion successful. As you may probably guess, collusion is going to be more likely and more successful, i.e. more likely to hold, if the number of competitors is small number of firms. It's always easier to strike agreement among just a couple of firms rather than a much larger amount. And also, if there is a single dominant player among them, dominant player, who can sort of orchestrate everything, it's going to be more difficult for sure. So let me maybe say over here, more difficult or less likely to be successful. Such a collusion is less likely to be successful if there is a large number of firms, which is kind of obvious. If I wrote small number of firms here, then large number of firms is the opposite. But plus if they have similar market share. If everybody has similar market share, so there isn't any one single clear leader among the firms, then there is much more chances or likelihood of having intense competition among them, which is absolutely the opposite of collusion, agreeing to do something together. Right. Number two, the second factor, product similarity. How similar is the thing being offered? And over here, if the product is homogeneous, i.e. very sort of, there is no difference between the products offered by the different companies, think crude oil, think perhaps natural gas, or maybe something like cement, then, companies are much more likely to work together to keep prices high. Whereas if there is product differentiation in place, that's going to make collusion more difficult, because everybody will perhaps, or the competitors may want to go their own separate ways and try to differentiate their product to keep their prices high, but not necessarily help the other competitors along the way. Now, number three, cost structure. This is something I'm going to talk about as well in just a moment when I talk about the optimal price and output quantity levels using charts. And you'll see that various competitors in an oligopoly different competitors may have different cost structures. Very often a leader is the leader because they've got the lowest cost structure, the most favorable cost structure. And the point is, if competitors have similar cost structures, then they are more likely to want to avoid a price war, price competition, which would be detrimental to all of them. However, when somebody has a lower cost structure than everybody else, maybe that somebody will find it beneficial to trigger a price war because they know they will survive, but others won't. So, that's a consideration. Now, from this point onwards, your book doesn't kind of tell you when things are more difficult. So I'm not going to say, I'm not going to necessarily write if they've got dissimilar cost structures that makes collusion more difficult. You kind of get the idea that over here we're going to have the opposite. Now, the fourth point is order size and the frequency of orders received by the companies. This may not be the most obvious one to everybody, but it's quite important. It's quite logical. In fact, collusion is likely to be successful if orders being received by pretty much everybody are relatively small in terms of their size, also quite frequent and regular, as opposed to big chunky orders happening from time to time. Now, why does this help and why does the other situation not help? Well, imagine, there's only a couple of orders that come in, big chunky orders, bulk huge orders that come in a couple of times during the year. In order to win that order, which will assure profitability for you, you may want to undercut prices and go lower than your competition just to win this. However, obviously, then breaking away from any price agreement that you may have struck before, that kind of bulkiness of an order, its size may provide it's enough of an allure, enough of an incentive to go against what you've pre-agreed with your competitors. On the other hand, if orders come in regularly, they're small and frequent, it will not really pay off to on a single order break away from the agreement. So it's more a case of an incentive to break away from an agreement if orders are big and chunky and come in less frequently. Okay, now there is another point here that I need to, two more points. Strength, sorry for the mistake, strength and severity of potential retaliation. So, what's going to be the force with which competitors will retaliate if you break the agreement? And obviously, collusion is going to be more successful if retaliation is expected to be, so the response is expected to be severe. That's quite obvious. It will provide less of an incentive to do something different than pre-agreed. And one more point. I'll make this point number 6, but it's really just a general idea. The degree of external competition. And here your curriculum kind of makes a more generic point, and that is, when cartels are formed to keep prices high, as for example OPEC does for oil, and restricts and puts limits on the output of oil by its crude oil by its members, that obviously attracts competition. And a good example, which is given in your book, is the case of traditional crude oil extraction from the from the ground or in the sea versus shale oil, which is shale oil being the extraction using a completely different process. It's much more difficult, it's much more costly to do, but because OPEC kept prices of oil high, it incentivized competitors to come up with better and more efficient, from a cost perspective, ways to extract oil alternatively, and that gave rise to another industry, the shale oil and shale gas, also industries, which, if the price of oil was kept low, would have not been the case. In a moment, I'm going to move on to a discussion of price and output levels in an oligopoly. Some sort of final conclusions bring together everything that we've discussed in this video and in the previous one. But before I do that, let me mention a small concept which may nevertheless be important, especially from a theoretical question perspective, namely the Stackelberg model, which is the Stackelberg model, which is yet another sort of pricing strategy. And the focus here is going to be on the advantage enjoyed by the first mover. So focus is on the first mover advantage. Now, why is this important, and how can this be potentially tested? Because it goes very much against something we discussed before, namely the Cournot assumption. You should remember that name, Cournot assumption. Okay, Cournot assumption. Over there, the point was that everybody, all the companies, all the firms, make their choices, make their moves simultaneously. Okay. Whereas under the Stackelberg model, that's not going to be the case, because of there being a first mover. It cannot be simultaneous. Companies over here are assumed to move sequentially. So obviously, the first mover is typically going to be the leader. Leader is the first one to make a choice. Leader chooses the level of output. And how they do this, we'll see in just a moment. Using a framework you should already know from previous videos at the quantity, which lies at the intersection of marginal cost and marginal revenue. Okay, I'll talk about this in a moment. Leader chooses their level of output, and I guess price as well at the same time. And then the followers, so the smaller competitors, go next. And the followers decide on their strategy given the choice or the choices made by the leader. That's what we mean by the first mover advantage. And obviously, you will not get numerical questions necessarily about this. It's more a concept that you need to understand, and associated with this idea of the Stackelberg model. One interesting conclusion from this: the profits enjoyed by the leader as a result will have every chance to be higher than the profits enjoyed by the followers, because of that first mover advantage. And one more term that I would like you to note potentially is the top dog strategy. Your book mentions this, and because it's mentioned, it's a very specific name, it may be tested. This is when the leader intentionally chooses to overproduce, to produce in such a huge amount so as to eliminate, quash, punish, potentially also eliminate, which is what I said initially, the followers. That's the idea of top dog, to take the market completely and punish your competitors, your followers. Okay, that's the Stackelberg model. Let me now use the rest of the space that I've got here to talk about optimal price and quantity. One thing that you may have heard me say before in connection with other types of market structures, for example, the monopolistic competition structure, is that the producer, and this goes for an oligopoly as well, does not have a well-defined supply function, in the sense that they cannot just decide on price and output levels or quantity levels independently of other competitors in the market, independently of demand conditions, etc. So, everything here is going to be interdependent. Now, we're going to use the idea of leaders and followers, as your book does as well, to discuss how, first of all, the leader makes a decision. And even though they don't have a distinct, well-defined supply function, they still have a cost curve. They've got a cost structure. So these decisions, leaders, by the leader, who's going to be the first mover, leaders' decisions regarding optimal price and quantity are going to be based on the cost curve and how the cost curve interacts with the revenue, marginal revenue curve. So something you should already be aware of from previous videos. So let me draw that classic picture. Over here, I'm going to have Q, that's the level of output or quantity, and over here, the price stroke cost. And like I did before, I'm going to draw a demand function, but I'm going to label this one DL. This is the demand function faced by the leader. And over here, the marginal revenue curve faced by the leader, and also a marginal cost curve. Once again, the one faced by the leader. And from previous studies, from previous videos, we should be 100% aware of the fact that in terms of the quantity choice or output choice, we choose a level of output which coincides, so this is the quantity produced by the leader, for which MC equals MR. Obviously, this is the leader's marginal cost exactly coincides with the leader's marginal revenue. And that's going to be the right point to choose. That's going to determine our quantity. On the basis of that, we can now choose a price, but we'll choose the price for a given output level, but based on where there is there is that intersection with the demand curve. Choose price from the demand curve. So on our graph here, that's DL. This is nothing new, but what I'm showing here is how you would always behave if you had that possibility to go first. So that's your DL demand curve for the leader, and that gives us a price level, right? The price charged by the leader, and this is for a given level of Q, which we got in the first step, the level of output. Okay, cool. Now, how will your competitors behave? If you are the leader, your competitors will be the followers. Now, the problem is, it's a problem for the followers, not for the leader, is that being a leader often comes about because you have a more favorable cost structure. So leaders often enjoy lower cost structures, in the sense that if this is their marginal cost level, you could imagine a similar line, but being drawn for the marginal cost, but for the followers. Okay, and they will now decide that they will now have to decide what to do. Because you are the dominant player, you are the leader, you will often be the price maker in the industry, or that company will be the price maker in the industry, and others will choose what to do. Very often, because of their higher costs, they will not try to fight you by charging a lower price. Undercutting your price would potentially for them mean starting a price war against somebody who can absorb even lower prices because they can produce at a lower unit cost. So from the perspective of the followers, it doesn't pay off to fight against you on a price level. They will either match your price or, in fact, sometimes potentially charge even a higher price. So let me put this down. Followers typically do not, it's an important point, it may be tested theoretically, undercut, so go below the price charged by the leader, PL. Why? They face higher costs, as exhibited by the marginal cost F of the followers. And this risks starting a price war against somebody who has a lower cost structure, against a lower cost leader. Not something you want to do because they've got the potential to absorb. The leader has the potential to absorb even a lower price. So the consequence of this is that often you see that the price charged by the followers is actually even higher than the price charged by the leader. So they sell for a higher price, or they try to, if there is room for that. Now, a really critical concept, and one that can make its way into a theoretical question very, very easily, is this idea of there not just being a demand function faced by the leader, but also another demand function, which I'm going to draw. Let me choose a completely different color, which I'm going to draw in this color. And I'm going to draw it. Let me be very careful about this. Okay, I wanted to make this line go at a different angle to DL. We're going to call this one DT. This is the total demand function as opposed to the demand function of the leader. And you will see that DT and DL are not parallel. And there is a very good reason for it, which you need to understand so as to be ready for potentially a theoretical question on this topic. Sorry, just got my finger a little dirty over here from the pen. Now, why is this the case? Because followers are typically assumed to face higher costs than the leader. So as I go along, I'm going to write stuff down. Followers typically face higher costs, cost structures as compared to the leader. So if prices go down, and obviously as a result, quantities sold are increased, if prices go down and quantities sold are increased, what will happen is some of those followers will start pulling out of business because they will not want to sell for a price which doesn't cover their cost, which is below their cost levels. Obviously, that's the decision to shut down and in a longer run, exit the industry. So if prices are okay, what will happen here? Smaller competitors, smaller followers exit the industry, they go out of business, and as a result, the market share of the leader, who can still, produce at and sell at these prices and still make a profit, their market share grows. Market share of leader becomes greater because, look, at any price level, you can see the level of output that's being produced by the leader. That's over here. That's this horizontal distance over here. And over here, you've got the output that's being produced by the followers. But as prices decrease, you see that this output, the quantity being produced by the followers, becomes smaller and smaller and smaller because there is less and less of them left, making more space for the leader only. This isn't necessarily a profitable strategy for the leader because the leader prefers to sell this quantity at which they they maximize their profits. But nevertheless, this is something quite important, and I believe there is a theoretical question in your learning ecosystem on what would happen if a smaller competitor starts a price war, starts undercutting the price charged by a leader. And the correct answer to that one is the market share of the leader would eventually or ultimately would increase. Now, one more point, which your curriculum also makes, concerning long-term profits. Long-run profits or profits in the long run in an oligopoly are absolutely possible. We're obviously talking about economic profits, not accounting profits. But please be aware of the fact that, as always, such profits attract new entrants. And that's something to always attract new entrants. So the classic story to always consider.